a pyramid starts as a square and 4 triangles, right? Oops, that's all not supposed to be there. A cone starts as a circle, and then we added that section of a circle. Yeah? All right. Well, now we're going to talk about spheres. Spheres are not like that. Spheres are a circle, but it's spun around in all infinite directions, right? There's no way to draw a flat sphere like we can draw a flat pyramid or a flat prism. Because if we squish a sphere down, we end up with just a circle, right? So it's impossible to show you how it's built like you can with prisms and pyramids. So we're going to go straight to the formulas, because the formulas are there. We already know them, and we figured them out from experimentation. The first one is easy. So a sphere is very simple. You can see it right there, 4 pi r squared. We already know what pi is. We already know what r squared is. We already know what 4 is. We don't really need to talk about the surface area of a sphere, do we? But we do need to talk about the surface area of a hemisphere. What is a hemisphere? Half of a sphere. And the reason we need to talk about it, you'd think it would be easy, right? So a sphere looks just like this. We've got it right there, yeah? You can see that that's a way to show it, right? Now, a hemisphere would be half of that, correct? Everyone agree? Okay. So logically, shouldn't the surface area of a hemisphere simply be a sphere divided by 2? That makes sense, right? So 4 pi r squared divided by 2. So it should be 2 pi r squared, shouldn't it? But what is surface area? What is the definition I gave you of surface area? The area that's exposed, right? So before I erased this, like this, could you see that circle in there? No, that's the middle of the sphere, right? But when I erase this, can you see that circle now? So is it exposed? It is. So do I have to count it in my surface area? So the 2 pi r squared, that covers all of this, the outside. What do I do to find this circle right there? How do I find the area of a circle? We've just done it like 17 times. Pi r squared. So it's 2 pi r squared plus another pi r squared. So if I have 2 pi r squareds there and one more pi r squared, then what is the area of a hemisphere? 2 pi r squareds and 1 pi r squareds. For how many? I know my grade 10 students can add 2 plus 1. 3 pi r squareds for a hemisphere. If it's solid. What if it's a bowl? You don't add the pi r squared, but then isn't the inside of that bowl visible? Which would be? What's 2 pi r squared times 2? Which would be a regular sphere. Everybody understand? Hollow hemisphere, same surface area as a regular sphere. Solid hemisphere, 3 pi r squareds. Cool? All right. Volume is a little trickier. Volume is we always write it this way. I hate that because that confuses you people. I like to write it this way. 4 pi r cubed. Then I like to divide the whole thing by 3. Because this is easier to do. But I don't care how you write it out. It's written right there. It's easy. We already know what r is. You find it from the drawing. You cube it. You multiply it by 4 pi. You divide by 3. Everybody's okay with that, right? The problem comes when we have to do the volume of a hemisphere. Does volume care about whether something's exposed or not, or is it just straight across half? Straight across half, right? This jug holds 1 liter of water. If I cut it in half right down here, it will hold how much? Well, nothing, because it would be cut in half. No, seriously. It would hold half a liter, right? Doesn't matter if I've exposed any part of it. It's going to hold half the amount of water, yeah? So in volume, we don't care about what's exposed, what isn't. We just do the work. So the volume of a hemisphere should be 4 pi r cubed over 3, but only half of that, right? Everyone agrees? So how do I make this half? I multiply by a half, which gets me 4 pi r cubed over, what's 3 times 2? 6. What should I do with 4 and 6? Reduce 2 pi r cubed over 3. Those are my hemispheres. They don't show up on any of your formula sheets because we expect you to be able to divide by 2 and understand that you're creating a new circle there. But I've shown you anyway. Everybody cool? Now, is there anything tricky about hemispheres and spheres, or do you just plug the numbers in from the drawing? You just plug the numbers in. There's nothing tricky, right? So the one question we're going to do on this as a group is going to take those very simple concepts, but we're going to pile them on top of each other, so it's a little bit of a tricky question. And the reason we're doing it is it's because, again, it's one of those real life things. And if you turn the page over, you'll see why. You'll think it's a stupid question, but when you look at it and think about it, it's actually a very serious real life question. So when you turn the page over, Jim placed 3 golf balls inside a cardboard box. The balls fit perfectly. The rest of the box is empty space. How could this possibly matter? I just said that there are real life people that care about this question. Who could possibly care about this question in the real world? Why is how we package things important? If you put something in a box, do you have to pay to make that box? Yeah. So if you have wasted space in your box, do you pay more for the box? Right. If I package my noodles in a box that is too big and I pay too much money for it at the factory, who does that affect at the end? You. You got to buy my noodles, right? If I pay too much for my packaging, then that is reflected in the price to you, right? One problem. Second problem. Do we have a garbage problem in the world? Yes, we do. Part of that garbage problem is over-packaging things. We need to stop doing that. How many of you have bought something from a store in a giant box, opened it up, and the thing is this big? All of you have, right? What did you do with that packaging? Threw it away. I know you recycled it, of course, but then it just went to the Philippines and got sent back to us anyway. So this is actually a real life question. I just, use it in math class because why not? So let's talk about this. How am I going to work this out? What math is happening here? What do I have? I got a cardboard box. What shape's a cardboard box? I got a rectangular prism. That rectangular prism is 3 by 3 by 9, right? And I'm going to fill that rectangular prism with golf balls, yes? So I got to know how much space is in that rectangular prism. How do I figure that out? Is it volume or surface area for how much space is inside? Great. So what's the volume of a rectangular prism? It's the easiest volume you can do. You got notes on it, and you got the little formula sheet. Area of base times height. What would you say is the base of this? And does it really matter what you make the base? No. So what would you say is the base of this thing? I'm going to try and draw this a little better. You would say the front rectangle's the base? That's cool. So, what's the area of the base? Madeline says the front rectangle's the base. So what is that area? 27 times what? Which is 3. So the volume of this box is what? You may need your calculator to do 27 times 3. That's okay. I won't make fun of you. 10 more. Mm-hmm. The volume of the box is 81. What am I putting in the box? How many? 3. What shape's a golf ball? Sphere. I'm putting the golf balls in. Am I taking up space, or am I painting the inside of the box? Taking up space. So I need to know the volume or the surface area of the golf ball. Which is it? Volume. Golf ball's a sphere, right? So volume of a sphere is 4 pi r cubed over 3, correct? Right? But how many golf balls are there? So what am I going to do with this volume? I'm going to multiply it by what? What happens to those 3's? So all the golf balls are 4 pi r cubed, right? Now since pi is in there, are we going to do a math class answer or a real life answer for this question? Why does this have to be a real life answer, Sahaj? Because it's a real life problem. We really do put golf balls into boxes, don't we? So we need a real life answer, right? If I had said 3 spheres are placed inside a rectangular prism, would you give me a real life answer or would you give me the pi answer? You give me the pi answer. But since it's real life, you're going to give me a real life answer. So what do I got to do here? How do I figure this out? What's my R? That's the tricky one. Look at the question. Tell me what you think R is. Because the first part's easy. 4 pi. Then I need an R cubed. What's R? Talk to your neighbor if you don't figure it out. Read the question. All the information is in the question. Then when you think you have the R, figure it out. Tell me the answer. Who thinks they know what R is? Rajveer, what's R? Pardon? 3 maybe? Okay. I have one guess of 3. Why do you think it's 3? I'm not saying if he's right or wrong. Why do you think it's 3? 3's in the question. You're absolutely correct. 3 is in the question. 3 times 3 is in the question. Okay, so we know that that golf ball is going to go in there, right? How far across is that golf ball?
Oh, I know.
How big is it?
It's half a centimeter.
Not quite. How far across is the golf ball? Because that would be the diameter, right?
1 centimeter.
It's 1.5, right? Because the radius is half a diameter. So this is going to be 1.5. And then you're going to do this work. 1.5 cubed times 4 times pi. And that's going to give you math class or real life answer. That's going to give you 13.5 pi. That's how much the golf balls are, right? What do I care about? What am I trying to get rid of when I'm packaging things? I'm trying to get rid of empty space, right? So I need to find out if my empty space here, what it is, if it's as small as it could be. So if the box is 81 and the golf balls are 13.5 pi, how do I find out the empty space?
Do 13.5 times pi and subtract it.
Right, it's subtraction. It's 81 minus 13.5 pi. Now, math class or real life answer? What's that? Math class answer. Am I happy with it? Sure. What's the real life answer? You're going to punch that into your calculator and round it off to 1, 2 decimals. I don't care. Because what's important to me? All of this or this last little answer here? Look how much space it takes up on the page. Which is more important? All this or that? Yellow or green? Yellow. But that answer is going to be something like 13.5 times 3 is going to be around 45. It's going to be around 36. 38. Blah, who cares? Everybody good? Once again, did we do any tricky math? No. We multiplied 3 numbers together, and we multiplied 3 numbers together. Is the math difficult? Not the math. Everything else is. And that's the problem with this. Everybody thinks, oh my God, I'm never going to be able to do it. The math is so hard. But the math is just multiplying. So, do not do that one. Do not do that one, because those are from another class, but I do want to talk about another type of question. Let's talk about this tent, but let's change this to let's just make this 8x. No, that's barfy. Screw it. Let's do this. This is 3. And this is 1. Let's call that 2. Let's call that 2. Tell me the surface area of that thing. That's your one practice before we have our quiz, which is in 25 minutes. So don't do this. Just tell me the surface area of that tent. Yeah, go. That is 2. That is 3. And they are all the same. And that is actually a really hard question. It seems easy, but it's really hard. See what people can do with it. This is what that triangle looks like, right? I've made it bigger, yeah? Right? So we can see that the base is 3, but we don't have this height. But I can make that height by drawing this. That's 2. What does that line do to this triangle? Cuts it in half. So what does that line do to 3? Cuts it in half to make this 1.5, right? When I cut it in half, what angle did I make right here? 90. Now, can I use Pythagoras to find this distance? Yeah. It's 2 squared minus 1.5 squared. Then I square root. Why is it minus? I thought it was a squared plus b squared. Because I'm trying to find a leg, I've got the hypotenuse. So that gives me 1.3. So now I know this is 1.3, and then I have base and I have height. A triangle is base times height divided by 2, but there's 2 triangles, right? So what do I multiply that by? And what do I do with 2 and 2? They cancel out. So base times height is 3 times 1.3. And that's where I got the 3.9 right there. And then I added it all up. Everybody cool? And once again, nothing new here, right? We already know how to do Pythagoras. It's just applying it in a different spot. Good? All right. So you have your quiz, I will tell you now, is 1, 2, 3, 4, and the fourth question has an A and a B part, but it's all open-ended. So, do you get points for all this? Yes. Do you know how to do every question on the quiz? Yes, because they're all the formulas and these type of questions. Do you know something about every single question on the quiz? Yep. So, is there any reason to leave any of it blank? Even if you're not sure, should you write something down? Because what if you get halfway there? Right? Everybody with me? Don't leave anything blank. How long do you feel you need for a 4-question open-ended quiz? I'm going to give you 25 minutes. Is that enough? All right. What do you do if you finish early? Work on page 217 to 220. When is that due? Tomorrow at 8:50. Do you wish to start your quiz right now? Okay. I'm going to give out the quiz right now. I lied. I have the quiz right here. If you wish to do your quiz right now, you have to come and get it. But if anybody gets it, all talking has to stop. Deal? So you got to work by yourself. If anybody wants this now. At 1 o'clock, everybody's starting it. So you can have 7 extra minutes with it right now if you want it. Okay. What do you need, Parm? It's like they're sending you up here. They're all scared. I'll come back to you, brother. No problem. I got to get up. I got to get my steps in, you know. You don't keep this slim and trim by sitting around on your ass. I know, right? Body like this takes work. Solid work. Usually lifting a fork to your mouth till your food. is starting his quiz 3 minutes early, so no more talking. Go. You going to start now? All right, everybody just come and get your quiz. Put your books away. You can have your formula sheet out. You can have that. Oh, wait. I promised the middle would get it first this time. Yeah. So go back to your desks. And I know some of you are looking at the screen and saying, maybe he'll forget to turn it off. I won't. I'm not stupid. Some of you are looking at the back wall there and saying, maybe he'll forget and leave that all up there. I won't. I'm not stupid. Take one, pass them back. And like I say, you can have your formula sheet out. When you finish, bring it to me, because I am going to mark this one because it's all work, and I want to give you credit for your work. Okay? So make sure your name is on it, and you bring it to the front, and then you go back to work on page 217 to 220. Yeah? Yeah, sure, you betcha. Wait a minute. Oh. What? What, huh? Where's the one I gave? I just gave it to you like 2 minutes ago. I don't have any in here. I will solve this problem. Keep working. That very first one, if you can't discern the drawing, it's a cone on top of a cylinder.